So post-stroke movement disorders represent 20 to 25% of movement disorders, or what you call secondary movement disorders, so not idiopathic. And we have very little data on that. And the data we have comes from short series, case reports, case series. And we tend to publish something new, but we don't tend to publish everything, what you call publication bias. So what we wanted to do is actually to create this big data set. As you can see here, 13 institutions from 9 different countries on all 5 continents to really gather this information of movement disorder after stroke. So what we found that the tremor was the most frequent phenotype, followed by dystonia and chorea, and then hemiparkinsonism. But that almost a third had the mixed movement disorder, like tremor and chorea, or dystonia and Parkinsonism, for example. What we found also is that there was some difference with some phenotypes coming earlier than others. For example, tremor, chorea, balism, myoclonus tend to develop sooner, within a week. Dystonia and Parkinsonism tend to appear 3 months or more later. We also found that some phenotypes tend to have a better prognosis. For example, chorea and balism were more likely to improve or resolve, versus Parkinsonism was less likely to improve or resolve. So that gives already an idea of, okay, you come to me, you had a stroke, and now you have a post-stroke chorea. Okay, we have a better outcome than post-stroke Parkinsonism. But what we found also is that there's no clear correlation between where the stroke is and what phenotype you're going to have. I mean, 20 years ago, we were taught and we were teaching that a stroke in the STN is going to give you hemibalismus on the other side. Now we realize that's not the case. A minority of stroke in the STN give you hemibalismus, and you have hemibalismus from stroke in other places. As you can see, 27% of the cases had basal ganglia stroke. That makes sense, right? Basal ganglia is where you have those movement disorders. 13% cerebellum. Yeah, tremor is a cerebellum. Okay, but what about the cortex? 28% had cortical lesion. We never thought that cortical lesion can cause movement disorders, right? What about 20.5% subcortical white matter lesion? So basically, this is really opening a big opportunity, and hopefully by mapping these, which will be another publication, another study completely, by mapping those, we might be able to say, okay, this is the circuit for chorea, this is the circuit for tremor, this is the circuit for this and that, and help us better understand what's going on and find new targets for deep brain stimulation or MRI guided ultrasound, etc.